Hello, my name is Katelyn VanvalKenburgh. In this video, I will be showing you the process I use to make bismuth crystals and explain how I was able to make different sized crystals. Bismuth is the most diamagnetic of all metals. The thermal conductivity is lower than any metal except mercury. It has a high electrical resistance and the highest Hall effect of any metal. The Hall effect is the increase in electrical resistance when placed in a magnetic field. Bismuth is used in a lot of everyday products. It is used in cosmetics to create a pearly effect. It is used in solder and fire prevention systems because it has a low melting point. It is used in pharmaceuticals, specifically Pepto-Bismol, and it is used as a catalyst in rubber production. If you plan on repeating this experiment, please remember that heating bismuth releases harmful bismuth oxide vapors, so please perform this experiment in a well-ventilated area. Molten bismuth could splash at any moment, so it is important to have your whole body protected and covered. I also recommend using heat-resistant gloves as you will be dealing with molten metal. This experiment is pretty simple and does not have very many steps. Here you can see a brief overview of the procedure, and now we're going to look at it step by step. I started with a block of bismuth. First, I heated it until it all melted. The melting point of bismuth is around 270 degrees Celsius, so this was easy to accomplish on the stove, but you can see that it took a while for the whole block to melt. Here, I'm just skimming the slag off the top to remove all of the oxides and other impurities. For the large crystals, I covered the bowl with aluminum foil and turned the stove down slowly to gradually reduce the heat. And for the small crystals, I just took the liquid bismuth off the heat entirely to guarantee rapid cooling. You can't let it cool for too long or you'll just end up with a puck of bismuth. The progress of cooling can be checked by tapping gently on the outside of the bowl. You should be able to see some solid sections that don't move when you tap. Once these sections form, you can decant the excess liquid into another bowl. Now let the crystals sit. They need about a half an hour to get to room temperature. Bismuth forms an A7 rhombohedral structure. This means that the cube is not at 90 degrees. It is slightly diagonal. So one side is higher than the other and has a higher relative surface area, causing the outside to form faster than the inside. The result of this interaction is stair-like crystals that progressively form more crystals around the outer edge, forming satisfying structures. The colors are actually formed from oxides on the surface, and pure bismuth is silver or gray. This is how the quickly cooled crystals turned out. You can see that there are many small crystals and they're not very detailed. This is what the slowly cooled crystal looks like. This is one crystal, and you can see the stair-like structures and how the outside grows faster than the inside. Thank you for watching me crystallize bismuth. Here are my final crystals. Remember to follow proper safety procedures if you try this on your own.